Number 54, we have the limit when x is approaching to 1 plus ln of x to the 7 minus 1 minus ln of x to the 5 minus 1. Imagine if you plug in 1 plus into all the x here. 1 plus to the 7th power is like 1 plus. 1 plus minus 1 is 0 plus. ln of 0 plus is like negative infinity. Let me write this down. Here you are going to end up with negative infinity, and you have the minus right here. And if you have 1 plus into x right here, 1 plus to the 5 it's also 1 plus, minus 1 is like 0 plus, ln of 0 plus is also negative infinity. In another word, what you are looking at this is negative infinity plus 0. This is an indeterminate form. It means that you will have to do more work. Well, the work that we're going to do is we're going to take the advantage of we are subtracting 2 ln, so we can use the ln property. When you're subtracting 2 ln, you can combine them into just 1 ln, and then the inside will be a quotient. Well, before that, let me write down the limit when x is approaching to 1 plus. These 2 ln can be combined into 1 ln because you are subtracting. So you just take the top, which is x to the 7 minus 1, and that will be divided by x to the 5 minus 1. Once again, if you're subtracting 2 ln, you can combine it into 1 ln, but the inside becomes a quotient. The first divided by the second, like this. And now, to continue with the next step, what we're going to do is, I'm going to focus on this part, right? This is ln of a function inside, like this. When you're taking limit of an ln, it's actually the same as ln of whatever the limit that you're trying to do. So let me write this down for you guys. In fact, I can pull the limit on the outside, to the outside. So I will get ln of the limit when x is approaching to 1 plus of this, x to the 7 minus 1 over x to the 5 minus 1. And the main reason that we can do this is because ln is a continuous function when you have when you're considering the numbers inside of its domain. ln is a continuous function. That's what makes me able to pull the ln out and then just look at the limit of these inside functions right here. Let me just kind of give you guys a better feeling. In fact, we've been doing this a lot. This is just an example on the side. Imagine I ask you, take the limit when x is approaching to pi over 2, sine of, let's say, 2x, like this. Well, what do you do with this? You pretty much just plug in pi over 2 into the x. But then in fact, what's happening is, because sine is a continuous function, so you can look at this limit as sine of the limit. So you can have sine right on the outside, and then you look at you pulling the limit inside, sine of the limit when x is approaching to pi over 2 of 2x. And then you pretty much just plug in pi over 2 into the x right here, and then you can work this out. And that's exactly what I did right here. I pull out the ln, I look at the limit of this part first, right? And I think you guys want me to finish this, so this is the sine of 2 times pi over 2, so let me just write this down like this. And that's the same as sine of pi, so this is like a pop quiz. What's sine of pi? And you should tell me 0. Anyways, you can scratch this out. But once again, the main idea is, if you have a continuous function, you can look at the limit of the function as the function of the limit, like this. That's what we're doing right here. And now, by looking at the inside, the limit when x is approaching to 1 plus, plugging 1 into all the x right here, you will get 1 to the 7, which is 1, minus 1 is 0, over 1 to the 5, which is 1, 1 minus 1 is 0. So this part, inside, it's a 0 over 0 situation. So we can use L'Hopital's rule on the inside. In another word, let us just differentiate the top and then differentiate the bottom to see what we are going to get. Alright, so I'm going to write this down, and let me just keep the ln in red. ln of the inside limit. We are still having the limit when x is approaching to 1 plus, like this, derivative of x plus 7 is just 7x plus 6. Derivative of negative 1 doesn't matter, it's 0. And then derivative of x plus 5 is 5x to the 4. And derivative of negative 1 is once again 0. And right here, we can calculate this limit when x is approaching to 1 plus. You can simplify the exponents, but in fact it doesn't matter because when you plug in 1 in here, you are just going to get 7 times 1 over 5 times 1. So inside, this limit turns out to be 7 over 5. But don't forget we still have the ln on the outside. Let me write this down first. We still have the ln, and then the inner part, this is going to be 7 over 5. So that's it. The answer to the original limit is equal to ln of 7 over 5. And let me change everything back to one single color black. This is the answer to that question.